Okay, now we'll officially start. I'll just, of course, wait on till absolutely everyone joins. But for now, I wish to discuss our specific panelists and how the panel is actually organized. My name is Ayla Janko, and I will be your host for this panel discussion. The panel discussion at hand is titled The Importance of STEM Education. Within this panel, the panelists are basically young individuals that have been both involved in academia and the industry, as well as their general scientific pathways are both heavily related within the STEM field, but are mostly and generally very diverse. However, within the panel, you'll all see how all of our panelists are somehow interconnected. So as a further ado, I will now give the brief introduction to each of our panelists, and you will see who we're actually dealing with within the panel. So Professor Leila Gurbetapovic is, of course, our biomedical engineer. She obtained her Ph.D. at International Birch University within the biomedical community, and she is a biomedical engineer. However, she has a very good and very specific background within the electrical engineering community, with both obtaining a bachelor and a master's degree. Currently, she works as a professor within various academic fields at the Faculty of Natural Sciences Engineering, International Birch University of Sarajevo, Bosnia and Herzegovina. However, she's also a technical manager at the medical devices of the laboratory Lab in Sarajevo. She also works as associate researcher at the University of Warwick, with this school being heavily influenced with applied biomedical tools and biomedical devices. Her main interests lie in artificial intelligence as well as various biomedical devices. She has been a representative and a form of ambassador for the biomedical community within Bosnia and Herzegovina, and especially being a woman in a male-dominated field, she has really truly shined on within her interests and specifically within the country of Bosnia and Herzegovina. Now, I would like to introduce Ona Ambrozaite. She is a specific and very interesting researcher that she's a very young researcher who graduated the University of Vermont in 2018 with she's basically obtained a Bachelor in Science within the biochemistry community within a minor of molecular genetics. She has been heavily involved with the Amgen Scholar Program, where she worked at a Japanese university within obtaining a very specific interest within the biomedical community as well as the bioengineering community, which all heavily ties into her interest in chemistry, where she now works within her field of pursuing a PhD degree at Johns Hopkins University. Her interests are very scattered, and in the sense that she started off with genetics and molecular genetics and then wandered off within the field of chemistry. Her PhD, of course, now heavily relies upon the fact that she has to tie in all of her interests within obtaining a specific line of interest within her studies. However, she studied the HAV1 virus with Professor Yorishima at the University of Japan, where she basically tried to incorporate all of these interests. She currently has the position of co-chair at the graduate representative organization at Johns Hopkins University, and she has experience with both doctoral students and postdoctoral students, where she basically has a way of connecting both the employees and the students within their professional development with their career path. Lisa Munoz is our certified scientific writing researcher, where she basically got hooked on science and within the science community very early on. She took a photograph within an electrical microscope when she was 14 of a fly's eye, and she has not looked back since. She has graduated with a degree of engineering at Cornell University. However, most of her interests in her 20-year-long career as a scientific writer and researcher have been focused on compiling a lot of complex and difficult topics within the scientific community and then making them digestible to the average viewer. She now works at the adaptation of a film, which is called Picture of a Scientist, and now adapting that into the book. So the panel is, of course, as you see now, very diverse. And of course, not last but not least, our Professor Amina Kurtovic-Kozaric. Professor Kozaric is a interesting scientific researcher that is heavily implied within the genetics community, the genomics community, and cytogenetics. Namely, she is currently a full-time professor at genetics and clinical biology at the Department of Natural Sciences Engineering, International Birch University, but however, she also works as a professor within the University of Sarajevo. Her interests have been sparked from hematology, cytogenetics, genomics, and she currently works as a head of lab within the scientific community now here in our country of Bosnia and Herzegovina. Her interests have been varied within genomic diagnostic, and she currently works as a head of the lab where diagnostic tests are constantly performed, both RNA sequencing, new generation sequencing, and fish application tools, where she basically has a very established path of research within the cytogenetics community. In 2012, she basically obtained a Fulbright scholar within Cleveland, within the Cleveland Clinic at the Department of Translational Hematology, where she incorporated all of her very specific and diverse interests into one whole field. So as you can see now, this panel is rather all over the place within their interests, but they're all kind of tied into one STEM educational field and one STEM educational path. Now, how are they all related and how are their experiences both different but then similar? So let's find out. Within the panel, I wanted to first find each of your individual experiences, how you've seen STEM education, how was your initial experiences and how they have changed as you've now grown within the community. So I would like to start with Ona because you have a very fresh point of view within the educational system as you are currently a PhD student. So I would like for you to share with our audience your experiences as a young researcher.
Yeah, thank you so much, Ayla, for the introductions and nice to virtually meet everyone. So my science kind of path started very early on in my, I guess, high school, where I took all the advanced chemistry and biology classes. And then when I got to Vermont to start my undergraduate degree in biochemistry, I spent all my summers doing research. So first summer I went to Kyoto, Japan, as Ayla mentioned, to work with Professor Yoshimura with the HIV virus. My mom was kind of scared to let me go, but we were not working with genetic materials, so that was not a problem. And then after the Amgen program, next summer in 2019, I went to Strasbourg in France at the Institute of Basic Supermolecular Biomaterials. And yeah, so my experience there actually was the spark that encouraged me to pursue like fields I was not familiar with. Before I went to Strasbourg to work on nanoparticles, for example, I was thinking, oh, I don't have any experience with that. How am I going to deal with this? But you go in there and you try to figure it out, and it was amazing. I saw that I could do it. So then when I was researching labs to join at Hopkins, I looked at the Kempa group, and I saw some, nanomaterials, and there was the unknown field to me at that point, what CVD, chemical vapor deposition was. And I thought, this lab looks interesting to me. So I reached out, and Zoom meetings happen, and then we can talk about this later. What's important when you choose your group? I talked to the graduate students in the lab, and that basically made me sure that I want to join the Kempa group, and it was a decision like I made before coming to Hopkins, basically. So yeah, and this is my first year in the Kempa group, and it's been incredible even through the pandemic. So I'm very glad by the choices that I made.
I find your story quite fascinating in a sense that you're still you jumped from basically biochemistry within the chemistry related field, and then a minor in molecular genetics. That is very diverse, but also quite similar. And a lot of our audience would not be aware of how genetics and genomics and cytogenetics are actually related. And now I would like to tie in all of this with Professor Amina. I would like for you to comment on your general experiences, because I know you have a very broad scientific and academic history within both cytogenetics and genetics in general.
Sure. Well, thank you very much for inviting me to this panel. And I would like to thank you, Ayla, and the BH Futures Foundation for inviting me to this panel. Thank you for the kind introduction, and thank you for including me in this young group, even though I may not be that young, but thank you for making me feel young. Let me give just a very brief introduction into my background in science. So I graduated from a high school in Philadelphia and then went to Cornell University. And I'm glad to see another Cornell alumnus here on the panel. So, and graduated from biological sciences department in 2002. And during, I knew I was going to go into science when I went there, but I didn't know exactly what. I knew I wanted to work on the micro field. I didn't, again, know exactly what. So the good thing about being at a university that has a research background is that you can go and work in different labs. So I had an incredible opportunity to basically from the day one to be able to work in a research lab. So I think that experience is very important to be able to practically work. It doesn't really matter what, whether it's microbiology, biochemistry, neuroscience, it's important to have kind of your foot in the door and just to feel kind of how science is done and how you go from doing the experiments and so on. There I basically, my whole university worked through in the lab, couple of different labs, also worked over the summer as a Howard Hughes scholar in different labs in New York. And then when I decided to go into PhD, again, undergrad was more biochemistry, molecular biology, not as much genetics, I would say, just to give kind of a sense of how you can switch from fields within biology. And then I came back to Bosnia to kind of see what I was going to do. And then I applied to a PhD program in Vienna, Austria. And looking at their publication list and so on, I realized it's an incredible place. So again, if you're coming from the US to Europe or from being in Europe or US, the system of being, at least in natural sciences, is slightly different. So I went directly into PhD program in Austria, and there I went into basic genetics. So I worked with Drosophila, where we basically studied genetics of the brain. Yeah, so it's neuroscience and genetics combined. And that was again different from what I did in the undergrad. So you can switch fields and learn along the way. Both undergrad experience and a PhD are all learning experiences. So the point is for you to learn the art of doing science, right? So you're actually being an artisan. You have to learn the tools of the trade. Right? So if we speak about biology, you have to learn how to do the PCR, how to do specific sets of experiments, and do it thousands of times so that you become an expert in it. I'm just giving the PCR as an example. Yeah, whatever. So it's, and during your PhD, you are also learning how to think. You do that a little bit in the undergrad, you start reading papers and so on, but in the PhD, you learn how to critically think within that field. So how do you design the experiments? What's good, what's not, what's the outcome? And then you start also thinking and planning a couple of steps ahead, right? If this experiment worked and gives specific results, what do I do next? So during your PhD, you are kind of learning how to work, a couple of steps in advance, as well as reading lots of literature in your specific field. Later on, during a postdoc, you're basically left on your own, not completely on your own. You still have your supervisor in the lab, but you're basically learning how to be scientist on your own, right? So like a toddler learning how to walk, right? So then you learn how to walk, right? How to do it yourself. And then once you think you're ready, if you go into academic science, you go ahead and then you can start your own lab. So, I mean, again, I could talk a lot about each of these steps. I don't know which one you're interested in, but I ended up working in Bosnia, and I set up a completely new lab that does diagnostics. So it's not research, it's diagnostics in molecular genetics and cytogenetics. So.
Thank you so much, Professor, for allowing this output that our viewers are going to probably find very interesting. Namely, I wanted this panel to be set up with a very different point of view. And this is why I wanted someone within a heavily academic background, within the background of switching between very different fields. And also, Lisa, I wanted to tie you up right here in between this discussion, because I find it also very important that your academic background is not what viewers might expect. So all of the panelists are STEM professionals, but your profession lies in scientific writing. So would you please give a brief introduction of how your experience has shaped your career path?
Yes, of course. Thank you very much. I'm happy to be here, and it's nice to meet all of the panelists and to hear your stories. As just explained, I am in science communications. I have a small business where I work with a lot of different scientists in academia and in industry to help make their work understandable to funders, to the public, to different types of groups. And when I started my career, or when I started my education, my higher education, I really thought I wanted to be a scientist or an engineer. And so I went to the engineering school at Cornell University a little bit before you, Amina, a couple of years before you, but I think we overlapped. So it's nice to have a fellow alumna.
Where did you graduate in?
2000.
Ah, okay. So I'm not that old. Good.
Yeah, no, I beat you. And so I went in fully expecting to get an engineering degree, which I did get, but I decided about halfway through my undergraduate program that I didn't actually want to be an engineer. And that was after I had done all of the very difficult introductory engineering coursework at Cornell, which was quite grueling. And I thought, oh no, I don't want to waste it. And I still really like science, but I don't know what I want to do. But I don't see myself in a lab. I had done some chemistry work in the lab. I had done a lot of different experiences, and I just didn't see it for me. So I started thinking about, well, what else am I good at that might be complementary to STEM, to science? And I realized that I like to write. I realized that I like to talk. And I had the fortunate experience at a sophomore seminar of meeting a journalist who worked in the sciences. And she was actually a meteorologist at CNN, the international news organization. And they were based in my hometown of Atlanta, Georgia. And so I asked her after her seminar, I said, hi, this sounds very interesting to me. Can I intern with you this summer in Atlanta? And she said, we've never had a science intern at CNN, but sure, write to me. And I ended up, that was my first experience in journalism and in communications. And so I realized once I was there that I didn't really want to be on air. I didn't want to be in the news in that way, but that I really did like science communications. And so I finished off my last 2 years at Cornell in a special program that they had just started when I was there called Science of the Earth Systems. And it was a very attractive program to me because it was multidisciplinary. I got to do biogeochemistry, geology, oceanography, atmospheric science, I could still keep my engineering program and all of the other stuff that I could do. And I could also combine it with journalism and science writing. So I quickly formed my own specialization and graduated with a degree in engineering and a specialization in science writing. And I was fortunate to be able to start working right away within the science communications field. I can briefly give a history of that. I don't want to take up too much time at this phase, but I worked for the first few years as a journalist, first for radio programs that were short programs about the environment and about nature. And then I went on to get a job working for an Earth Science magazine, where I worked for a number of years as a reporter and then as a managing editor. And then I decided to shift my career several years in to be on the other side of science communications. So you have the journalists who report out all the news, and then you have the people who work at the scientific institutions who help to tell them what to cover. And so I went and lived in Geneva, Switzerland for a few years as a press officer at the World Meteorological Organization, which was a wonderful experience. And when I returned to the United States after that, I decided to start my own business. I had a small baby. I decided that it was time to do something different. And so I have been doing that ever since for a while now. And I get to work across many different scientific disciplines with many types of scientists. And so I work very closely with academia, even though I'm not within academia. I work with biotechnologists, earth scientists, people in medicine, artificial intelligence, any scientific field you can think of. And briefly, I'll just say I've found my STEM education very important to every part of my career because it's taught me fundamental skills and critical thinking. Every day I learn something new in science. Almost every day I have to read a journal article. I have to know how to speak with scientists. There's a whole ecosystem set up around that. And my education was very important in paving the way for where I am today.
Thank you so much, Lisa. Our audience can basically guess, we're kind of dwindling down from like science to engineering. We're switching gears. So Professor Leila, I wanted you for this panel because you're basically our designated electrical engineer. You have a background that is incredibly important for the scientific community and for science in general, genetics, biology, but most people don't really associate electrical engineering, and especially when it's within a field that you're basically tying everything together. So I really want your kind of stepping stone of how you decided this, how your experience has shaped you, and how you've actually chosen all of this.
Thank you, Ayla. Hi, everyone. Thank you, Ayla, for organizing such an interesting panel and joining us all together. Well, for me, it was, I'll say, pretty simple. At the beginning, when I finished high school, I was thinking about studying either medicine or engineering, but it was pretty simple because I'm so afraid of the blood. So engineering was logical approach. And then I chose electrical engineering. So specifically, I have chosen automatic control robotics and electronic engineering because the robots are the future and the innovation in that sector is the future. And that was something really interesting. And as I have heard from my previous colleagues, somehow during my bachelor studies, even though I really liked robotics, I really liked electrical engineering, somehow I didn't fit in there. Somehow it didn't had a purpose in everything. So I searched for something. I searched for something that will combine this love toward the medicine and biology and chemistry. And then I had one course in my master's study, which was called Biomedical Engineering. And it is funny, but it was like a destiny happening over there. I just had one lecture with my professor in that time. And then I knew it was love on the first sight because I got really interested in the field. And it was funny because biomedical engineering was something unknown in Bosnia and Herzegovina, but I was dedicated to do some work there. And then some things happened, some things followed one into another, and I started working in that field, but it was followed by my master thesis. And after that, I got, let's say, summer practice in one company in Bosnia and Herzegovina, and that was among the first companies specifically working in the field of biomedical engineering, but not any type of biomedical engineering. I'm not talking about any complex biology systems or chemistry systems or something like that. They were working with medical devices, and that was it. It was joining the medical application, the medical part with my electrical engineering background. And immediately I knew that was it. So I got my specialization in this field. Then I enrolled in PhD studies at International Board University, because at that point it was the only university which offered actually doctoral studies in this field. And I have finished my doctoral studies in the field of metrology and medical devices. And actually that is summed up in one field of clinical engineering. So in that, let's say, 3 to 4 year period, we did some extensive research, some extensive work, and we've been able to place Bosnia and Herzegovina on the radar of biomedical engineering and clinical engineering within the research and scientific international community. So, so far we have established one professional society for biomedical engineering. We have established one international conference dealing only about biomedical engineering, and we have our activities within this company, which is providing activities related to medical devices. So you can see here that all this path was from the education, from the university, to the business part, to the application. And that is very, very important to stress out, because myself, when I was a student, I was learning all those complex equations, systems, and everything. And I was wondering, oh gosh, where will I apply these things in the future? So for sure, you will apply those things somewhere if you are going to work in that field. And not just that, you will learn a lot more things which you will need to be very successful in your field. My previous colleagues during these presentations, they said some key words. So they said critical thinking, academic literacy, or scientific writing, and they mentioned a little bit innovation and research. So those are those crucial skills that you acquire through the education in STEM. Whether you're talking about science, whether you're talking about technology, or engineering or mathematics, you actually, through your education, as did I, you learn the model of thinking of, you have a problem, you know which tools to use, and you know what kind of solution you're expecting. And for sure, you know how to apply that solution. And that is the real value of your education, when and how you apply that education in real life. So that is my story. I like to say it was a destiny, because I really like and love actually the field that I'm working in, and then nothing is too hard when you're doing it from the heart.
Thank you so much, Professor Layla. I think that last sentence is truly beautiful, and I think it basically sums up the entire panel. So the panel that I wanted to have is a panel that had different experiences. So as we've seen here in both my introduction of them in their own words, it basically gives out a message that it's not that scary to switch a field. Fields, either scientific within the STEM field, you can basically skip within the entire branch. How so? Well, they're all kind of connected, and STEM is very broad. So you can be connected either in scientific writing, as with Lisa, or you can either skip fields that don't seem related, as Professor Layla, or you can go through academia with what seems from the outside point of view as a very straight line, just like Professor Kozovich and Ona. It kind of seems that the panel is basically set up in a way that we have two very different points of view. So I want you all to address more specifically. I'm going to pair you up with what I believe is going to be most related to each of you. So for this question, I would like to pair up Ona and Professor Kozovich. I want to know what you believe, what you actually believed STEM was, and what surprised you when you got within a lab. How did that kind of switch your perspective? So I would like to start with Professor Kozovich.
So how my perspective changed once I got in the lab. So I would like to tell a story when I went and started doing my PhD in neurogenetics in Vienna. When I first came, I mean, I had obviously very good scientific background. I was in the lab for 4 years, even in high school. So, and then I remember when I went in and looked at the first experiments that they had with Drosophila, I mean, I felt like I was in a Harry Potter world. I mean, it felt like just new rules, completely new world. It was, and I remember being in the first several months, listening to lab meetings and all the reports from, you know, people in the lab, where I didn't understand half the things they said, right, in the beginning, right? So, but it was incredibly fascinating, right? So it literally felt like you went into this magical world and you were taught how to use all these different tools in order to solve a specific question. So that was, I think, a nice kind of an analogy to how a student may feel once they enter a lab, even if it's a different field. I just recently read a story where they talked about original molecular biologists who, many of them were physicists. Actually, my supervisor during my PhD was originally a physicist who switched over to molecular biology, to genetics. So switching from physics going into biology, or from biology into another field, you should just have curiosity with you. Everything else comes along and you will learn it. So, and again, I think for people who are either going into undergrad or going into graduate studies, if you have the curious mind, I think you can, you know, overcome any of those things that you learn along the way. So it's incredibly nice, incredibly beautiful to be for me, in a research setting where you learn new tools. So switching between the fields, I think, is great. Even if you go from a PhD to a postdoc, it's even suggested that you switch, right? That you don't, either you switch model organism or you switch the field, right? I mean, you can do both as well, but it's suggested you do, because you carry with you the tools you learn from one field, and then you learn a new set of fields, and then later on you can kind of combine them.
Do you think that, sorry, Ona, I'm going to get to you. I really want your perspective because it's very fresh. But Professor, do you think that that experience, that switching, was that kind of terrifying to you, or was that just a natural progression? What do young professionals go through when they go through that experience?
I think you shouldn't be scared, right? You should just see it as a new challenge. So again, when I was setting up my own lab, right, it was again a new field that I was entering, right? So for me, it's the scientific curiosity and challenge that is kind of what drives if you're in a scientific field. So again, some may be more adventurous than others, and it's fine, but I think switching fields is completely desirable and should not be scared of, right? I mean, I think throughout your studies, you've learned how to learn, right? So it's not a problem of learning, right? It's you know, learning those tools well and applying them later on. So there are many people who switch fields. So either, again, they keep a little bit of maybe they keep the model organism and they switch the fields and so on. So many people do this. So it's not something that's unknown, and it's even encouraged, right? So so that you can bring a fresh and new perspective, right? Because if you're in the same field for a very long time, you kind of have your own set mind. But when somebody comes from a new field, right, they will ask questions which may not be very obvious to you at first, or you may not have think about. So I think it's a good strategy. And I think, and again, as I've said with the physicists, right, the physicists jumped into biology in the 60s because, or, at that time, 50s, 60s, because they wanted a new challenge, right? And they even weren't called at that time molecular biologists or whatever. I'm sorry, I don't remember the article that I'm referring to. I may look it up later. But again, switching fields, I think in my opinion, it's desirable.
Absolutely. So switching fields can be challenging for some people, but I think it's important for students to have that different perspective and that different academic approach. So Ona, you had a very interesting story where you basically studied at Kyoto University and you had a different educator. So this educator kind of broadened up both your horizons as a student, but then you had a practical way of dealing within the lab that wasn't present before. You spoke to me about learning things and methods that this was your first time experiencing it. So how was this experience for you? And how was this switch between the textbook and the lab in real time?
Yeah, so during my time in Kyoto with the Amgen program, of course, I had a chance to, for the first time, be in a lab and responsible for a certain part of a project. And Professor Yoshimura truly showed me what kind of PI is, not what kind of PI, but he's hands-on, for example, and he would show me how to pipette. So would sit down with me and show me the most fundamental or easy things. You might think it's very easy, but the professor would just come by and show me. So I saw what kind of leadership there can be in a laboratory, and I also was trusted enough to use the confocal microscope at the university, which, being back, would require a lot of confidence from a professor, because it's a new student. I've never been exposed to those microscopes before, and it's pretty expensive. So I always had to keep that in mind. But that additional responsibility was something new to me as well. And working with cells and collaborating with other laboratories at the university, or asking someone to do something for you, which for example, I never had to do before in my undergraduate time. So yeah, that was my first kind of dive into a real research environment for a longer time, for about 2 months. Yeah, I can talk about the other experience in Strasbourg if needed, but
I really want to know how, because this is, as you said, this is very fresh to you, and this is very new, but it's also very recent. Do you believe that it's crucial for any STEM educator to kind of relinquish control within the laboratory and give the students the time and effort within the lab to actually experience and feel within the lab, even though there are newcomers and there are new conflating interests? So do you think it's crucial to have practical skills, and in which way?
Oh yeah, of course. I mean, if from the skills that I gained in Kyoto were different from the skills I gained in France a year later. So having all of that and coming into a PhD program, for example, my lab mates, they're doing nanoparticle synthesis, and I know exactly what's going on, even though I don't participate in the experiments myself there. But I guess for me, being able to learn those new skills quickly and adapt to this completely new field in a few months, that helped me to now be in this position in the PhD, where we have a chemical vapor deposition reactor, and you also have to learn quickly in a few months how to do it. And for me, that's the fun of it, that you don't stay kind of stagnant in one place. And my knowledge can go from like molecular genetics or how cells divide to how low dimensional materials are synthesized. So anything you learn will help you along the way, especially those practical skills.
Was it difficult to jump from like straight into the lab, or did you find that experience? Was it of course it was easier the second time around in France, but do you think it was more difficult because it was first time, or because you had that kind of premonition of just something happening?
Yeah, I think the first time, I think that the Professor Ishimura made it so much better because he's just so inclusive and he's friendly. I think that lab environment matters so much. We can again talk later more about what it is like and how to choose a laboratory. But it wasn't personally very hard. It was just new. For example, presentations during lab meetings, which is what PhD students have to learn one way or another. So yeah, having those presentations, having a poster, creating a poster, how do you edit it? How do you communicate with the professor about those edits? And yeah, so it wasn't particularly hard. It was just new and exciting, and that was driving me to go there every morning at 6 in the morning. So in the summer, it's really hot in Kyoto. So go there and just read papers, like especially reading those reviews about the field. That's the first thing I had to do when I came into the lab in Kyoto. I had to read those papers, and that was also new. So I never used to be a daily reader of scientific communication.
That scientific literacy and that scientific motivation is of course very important, and you kind of learn it along the way. But that switch is kind of very fascinating to me. So this question I want to split off within Professor Gorbeta and Lisa, because you had a very unique experiences where your experiences was basically shaped within one field. You kind of thought that was going to be just the way it goes, and then that switch happened. So I think a lot of students are actually afraid and have different opinions of how that switch is supposed to look like, if they're scared of that switch, of how that switch will actually affect it. So I want this question to be based on, did you have any like discrepancies between your choosing? Did you just like go straight in? Did you head first jump in, or did you find it difficult at first? So Lisa, what do you think is, because of course you wanted to be a scientist or engineer, but did you actually consciously process that switch, or was that just natural for you?
It's an interesting question. I think I did process that it was a switch because I did have to put actually quite a lot of work into setting up the major that I had, because I was in the engineering school and I had to pivot and change my path. But at the same time, it did feel natural to me. I knew I needed to do it, and I felt confident at the point that I made that decision that I was going in the right direction. I also felt like I had enough flexibility where I would still have my engineering degree, but be able to pursue the topics that I knew I wanted to pursue. And so in that sense, I was very fortunate that I was at a university and in a program and had mentors and advisors who supported me in doing that. But all of that said, I think when I first started doing science writing and journalism classes, I was terrified. It was something that was new to me. I had never written in that way, even though I had done a little bit of work like that in high school. And then I would say that every year since, in 21 years of this work, I am terrified every time I get a new project. I have to make changes all the time. I started off in radio, then where I was writing 100 words at a time. Then I had to start writing 1,500 word feature articles when I worked for a magazine. Then as my career has evolved, I've had to learn different scientific topics almost monthly for 21 years. I've had to learn how to work in video, work on websites, in any medium that you can think of. And every time I am terrified, but the way that I think about it is if you're a little afraid, it's probably a good thing because it means that you're trying something new. You're challenging yourself in a good way. That's part, as Amina said, of sort of this drive that we all have, this curiosity to learn about the world. And I think it's, you don't want to be controlled by your fear, but it's good to have a little bit of fear because it means you're probably doing something right. You're following your heart. You're going to where you think it goes, even if it isn't comfortable for you. So I encourage people, as long as they are interested in following their interests, to take those risks and to start being comfortable being a little afraid, because I think it's overall beneficial.
Absolutely. Do you think that shift changed you as a person, or did it just help you develop your professional and academic career? Do you think it kind of like unbalanced you for like at least a little bit?
I don't recall that. I don't necessarily think about things in discrete moments in time, maybe because I've been doing what I've been doing for a long time, and there is a lot of change in my work all the time. And so I think more about the overall growth. And so there are moments that I can think back where I said, oh my gosh, what am I doing? I still like what I'm doing, but I'm scared, or what if I can't do this? Or what if it doesn't work out? What if I fail? And there have been many times, including when I graduated from college looking for jobs, where I had to apply to so many jobs and you get rejections, and that's all part of your growth as an individual. And so I think that there are moments in time where you feel unbalanced, where you say, wow, I've submitted 10 applications and I haven't heard from anybody. And what if it doesn't happen? And what if I'm on the wrong path? But again, I think as long as you're staying true to your interests and you're putting your best work forward, it's okay. It balances out with those moments of imbalance.
Absolutely. I think it's important, just like you said. I think that's very crucial. And I think a lot of young students kind of like shift away from when they're out of their comfort zone. But in order to succeed as a scientific researcher, academic, or anything, you have to actually just step out and move within a field that's different for you. So Professor Leila, you moved within a field that was not just different for you, it was different for the country. It was very new, it was very novel, so it had its own set of challenges. So do you think that shift between electrical engineering and biomedical sciences was conscious on your sense, or was it just like, okay, I'm just getting head first within this is what I want, I'm sure?
It was really intuitive switch. Actually, you can hear from all four stories that it took some courage to follow your interests. And we were all motivated by our interests deep down. We wanted to do that for a living. So we had the courage to follow our interests. We had the confidence in ourselves. Sometimes you lose this confidence, but it is really important to have the support around you to go and proceed with the interests. And of course, you never lose your determination. Even if someone tells you you cannot do that, then you need to get even more motivated to fulfill that goal. So Professor Kozaric mentioned very, very good that during our education at bachelor, at master's, at PhD, we learn how to learn. We learn how to study. And then when you come into the field, whether you're working in academia as a professor, or if you're working as a professional in the field, you always need to investigate. You always need to improve, and you always need to go to your limits in order to achieve something which is applicable in the field. So it never stops being challenging. When it stops being challenging, you're not doing something good. And that is also what what you learn from the faculty. So when you finish with the exam, you're finished, you move on, and you are being determined to finish something else. So it is really like that in the practice as well. What I try to do with my students, I try to learn them how to learn, and more importantly, how to do the research. Because with the internet, with variety of tools, the knowledge and information is just around the corner. You need to learn how to optimize your searching skills and your research skills in order to produce the results. So that is also one benefit from the STEM education and the methodology that we learn. So my shift was pretty natural because I was really, really motivated in working in the biomedical field. And it is challenging even today because we are always trying to do something more. And it is really motivating to see my students who are interested in this field. And it is very good to see new job opportunities opening in our country. And I have read the information that around 60% of the jobs still don't exist in the future, for which we are educating our young people. So that is the power of STEM. And I have also read that the economy of the countries will rely on the young people which are educated in this field. Whether we are talking about technology, whether we are talking about engineering or natural scientists. Still, there are a lot of things to be researched, still a lot of things to be explored. And for sure, during the interdisciplinarity of the fields, new opportunities will open, and we need young people who are very motivated, but capable to adjust in different fields. And that is why switching from field to field, which are related together, shouldn't be a struggle for any young person.
I absolutely agree. I think a lot of professionals or students kind of believe that that switch is a negative thing because we've been kind of drilled into our own head that you just have to pick one, master one, and just go straight ahead. But actually, you gain a lot of scientific curiosity from actually researching more fields and gaining knowledge in each of them. So for the next question, I would really like to pair you off, Professor Leyla, with Professor Concise, of course, with you, both of you being long-term STEM educators. You've had various groups of students with various personalities and various scientific interests. So I wish for both of you, starting right off, Professor Leyla, to go off and go, what actually was the impetus for you to become an educator? It was, of course, you wanted to give, basically have that knowledge that you obtained be passed on to other individuals. But what do you take every day to your classroom? What thought, what method, and what mindset you enter a classroom? So Professor Leyla, would you start off?
It was really good that I entered the academia as an educator right after my studies, because at that point I knew whatever I hated from my educators, and I wanted to change that with my students. So every day when I go into the class, I try to tell them stories from the experience, because I'm very lucky to be working partly in academia and partly in the professional field of biomedical engineering here in Bosnia and Herzegovina and international area. So I want them to learn that interdisciplinarity is the key. For example, if you're an educated professional in biomedical engineering, and if you go to work in a company, they're expecting you to know biomedical engineering or some specific area in that field, but they also expect you to know a lot of more things: how to talk to each other, what is fax, what is professional writing, how to write a professional email, how to talk with other people, how to conduct the meetings, and to have a confidence while doing that. And I try to pass that knowledge, how to behave in a professional experience, knowing all about your specialty, but how to behave in a company and how to be attractive in the labor market. That is really important, because if you have all the knowledge, but if you don't know how to represent the knowledge, how to simplify the knowledge to other listeners who are not from the professional community, then you won't be able to succeed as if you know and have these skills. So, you know what, in some countries, for example, in our country, some of the academia portfolio is still not aligned very well with the labor market. So that is why our students need to push harder in search for that knowledge that is that is searched for in the labor market.
I definitely agree. It has to be coming from a place where they're actually understand a difficult concept and can explain it in simple terms. So if you can't understand it and explain it to someone, a layman, you don't really understand it. So Professor Concise, do you have a specific way of approaching a classroom? Just like Professor Gruber said, you have to have a way or a method where you actually go within the students, interact with the students, and then pass on that knowledge. So how do you approach important information?
It's a really good question. So first of all, not everyone has the skill of being an educator. You can be an excellent scientist and not have the skill of being an educator. So being an educator and being able to transfer the knowledge to your students is a specific skill, and you have to love it. And actually, even a lot of scientists are not very excited about teaching. So it's not something that scientists, this is a very broad generalization, are very very prone to. Yeah. So I love educating, right? So one of the important things about educating that I found is that I share my love and passion for science, right? That's what I do, right? So if I transfer that feeling of loving what I'm doing and being passionate about genetics, molecular biology, genomics, whatever I'm teaching, and that's what the students can feel. And being able to tell them, yes, you learned this is just the basis, go on, right? So being able to instill in them the will and desire to learn more, right? Not just, okay, I'm going to come here, I'm going to do this exam and I'm out, right? That's not the point. The point is to wake up in the student. I don't know if I'm using the correct word, to kind of wake up the desire to learn more and to be curious, right? So that's because if I do that, they will learn the facts that they need along the way, right? So, but being able to transfer that love and passion for science is what will drive them into that field, right? So I've had students, let's say, in Amgen programs since 2009, right? So yeah, so, and they've gone into, PhD studies, master studies, and so on. And I think it's because I show them how I approach science, right? So that idea of constant curiosity. So when I teach molecular biology, let's say, or genetics, I teach them the facts, but then I say, how did they get this result? What was the experiment that they conducted in order to find those results? And then I may tell even a personal story of what somebody in the lab may do, right? In order to get that result, right? And then it's very important in the classroom to make sure that the students are engaged in the classroom, right? So that they are active listeners, right? So that I just go in there. I also have bad days, right? So I go in and I just, teach, and you're not always your best. And I've been teaching since 2007. So, but it's important to when you go into the classroom and that's what I'm missing with this online school, and that that's why I'm not very fond of the online school. Personally, I like the interaction with students, so I can say, I can explain something and I can get their opinion, and then we can move on, right? So I get them thinking also in the classroom. So, and also I think it's important to be strict. Very kind of basic things in the classroom, right? You have to be strict. You have to be strict, and you have to require a specific amount of knowledge, right? So they have to study, they have to learn, right? But they have to leave the course with the desire of wanting to learn more.
That's actually wonderfully put. I think it's very important to just not just motivate students to get a good grade, if they're just supposed to take that knowledge and impart it on different people and use it constantly within the field. So on that, while it's important to actually master a scientific discipline or your career path or something that you're passionate about, it's also very important to take down specific complex concepts and then break them down to their very simplistic meanings. So Lisa, you've managed to actually take loads and loads of information that's very complicated to explain to anyone just passing within the street. But you also managed to explain in a way that it stays true to the actual scientific thing that you're explaining and generally elucidating. And Ona, while you always manage to be within the lab and within various fields, it's also important to know that when you're actually choosing a lab and you're actually choosing your professor that you're going to be working with for a long time, you also have to take something that's essentially complicated and a lot of options, a lot of fields, a lot of specialities, and then taking it down, okay, what's the simplest way that I can look at this? So how has your approach been to actually choosing a lab, choosing a mentor, and choosing a specific supervisor for a specific field?
Yeah, so I guess I can expand on how I chose my current lab, the Kempa group here at Hopkins for my PhD studies. So I guess this was very different from what you would normally do during your visitation weekends. For example, for your PhD programs, at least in the United States, you go and visit, all right, and you spend a few days, meeting the professors, talking to them. Maybe meeting the grad students in the labs and seeing other students who are potentially coming into the same program. So we didn't have that this year, last year. And that required us to take this initiative, basically to email the professors, right? Not be afraid of saying, hi, I'm interested in your laboratory, and do you have a space for another student potentially? And I saw that some people in our cohort would have they were not as comfortable doing that. So that was another challenge, I guess, for the pandemic, new PhD students. But yeah, what I think is that you have to take that initiative. You have to write those emails, and there will be no's. Of course, there will be rejections, but that yes will come if you put in enough time and you look deep enough. So in my case, as I mentioned before, I looked at the research interests of the professors. Usually the lab websites have them. And then I set up Zoom meetings with Professor Kempa, and I saw, how he thinks. So what could I do potentially in the lab? And then during the virtual visitation weekend, we had a chance to not only talk to him again, but also talk to the students in the laboratory. And they truly gave their honest opinions about their work, about the laboratory environment. And then I could tell that they are happy people. So I saw when I heard that they chose the laboratory because of our professor, that had a big impact on my decision as well. When I realized that they are able to do their science, they're able to publish amazing results, and also be happy, have that work-life balance. That was so important to me personally, that I knew immediately that after that conversation on Zoom, I said, okay, yes, I'm joining this lab. So it was very I guess easy that I was able to match or click with the people in the lab so fast. For others, it took just some more time. When things started to open up, they could actually go into laboratories, explore, see what the subject is. Some people might go in and they see that they want a more hands-on professor. Some professors are more hands-off. They allow you to lead the project and you just meet with them once in a while. And in my case, for example, we have weekly meetings, so that you also have to think about, do you like a professor who directs you more? Do you like your own to work more by your own schedule and meet with the professor less often? So that's also something to think about going into laboratory. And again, the people who you're going to work with. If you see you can, then go ahead. But sometimes you see that you don't fit in, and that's okay. There are plenty of options out there.
So yeah, that's how you take something that's at first glance very difficult to choose and very difficult to kind of decide, because you have to take in a lot of factors. And I really want to stress this to all of our viewers. This is if choosing a PhD program is of course a huge commitment. I mean, I wouldn't know personally, but I'm aware of the fact that this is a year-long process and you're going to be stuck with that supervisor, that group of people, that mentor for integral part of your career. So choosing this and choosing a way to actually simplify it in the simplest terms is incredibly important. So Lisa, when you were actually, we've already spoken about the importance of literacy when choosing scientific disciplines and working with different personalities. I mean, you've had to have worked and talked to a plethora of people just to simply go through a topic or through a field. How have you found your experience in scientific writing to be different from others?
Different from others in scientific writing, or I'm sorry, I didn't totally follow your question.
Were you aware of the fact that your scientific writing is going to be, of course, shaped by your own experiences?
Yes, of course. I mean, ultimately, my job, even though I don't work in journalism anymore directly, is about telling the stories of scientists. So my job is, of course, there's a lot of facts, there's a lot of scientific information that needs to be processed, but ultimately I talk to people and learn their stories, what has shaped their interests, and learn about their work through their own eyes. And so as you do that, like anything over time, you become better at listening, better at whatever it is that you're doing. Practice is everything, right? So the more that you practice a skill and the more that you apply it in different settings, the easier it becomes. And so, of course, all of the work that I do now is shaped by 20 years of very varied experiences across fields, talking and working with a lot of different scientists, a lot of different writers, a lot of different creative professionals, people in business. I work with startups as well. I run my own business. So everything that you go through and do in life, you can somehow apply within your work to become better, to adapt, to grow in what you're doing while still following the same interests.
I have a question. What's your favorite scientific field? Because you really have covered a lot of them.
I mean, I guess my scientific home is in the earth sciences, although I work the least in it now. But when I was in the earth science program, I really fell in love with it. I worked on a research ship for 6 weeks. So I have a lot of passion for climate work at the intersection of oceanography and atmospheric science, even though I haven't worked in that in a long time. But I'm actually here I'm on vacation this week and I'm at the beach right now. And so I'm close to the ocean. And so It's a nice place for me to remember my scientific roots, even though most of what I do right now is in neuroscience and biotechnology. But the best part of what I do, like I said, is I tell people stories. So I believe I've worked with Ona before on a story for Amgen Scholars. I've worked with Isla before. I've probably interviewed, I haven't counted it, but hundreds, if not more, scientists from all different fields. And it's always just so interesting for me to hear from them where their passions are, how they've evolved, and how they've been able to take that and make the world a more interesting or better place with that passion. So that's very exciting to me every day.
And Lisa, what would you say that it is one same thing for all the researchers that you have interviewed?
I think that all researchers, especially early career researchers, like most people, don't always know how to talk about themselves and their work in a personal way. I think that I think it's getting better, but I think that traditionally scientists are raised academically to think of their science as being this objective truth that they are following that is somehow independent of their personality. And so a lot of the work that I do is to make people feel comfortable expressing their work through their personality and their personality through their work. And I think that that's actually changed a lot in the world in the last several years. I think, I hope and I think that especially the next generation of scientists, that they're bringing their whole selves into their work and not feeling the need to separate it. And so I wouldn't say it's everybody, but I would say that to some extent, everybody struggles with that. I would say everybody hates hearing themselves on camera or listening to themselves talk about their work. That's universal. So that's everybody.
That was my point. The same, actually. We need to learn how to talk about the research that we are doing on more subjective manner to represent it.
Yes,
that is really important.
I see it a lot with the Amgen scholars. When I interview them, I say, can you tell me in 30 seconds what you're working on? And they're thinking so much about the details and getting every detail right that they forget why they became involved. And so sometimes the question isn't what are you working on? It's why are you researching this? Why do you do what you do?
Yeah, that is actually one rule that we have adopted in our company. When we want to do some major science, major research, the first question is why and where. And when we find the answer to those most simple questions, then we do complex science after that.
Absolutely.
So Lisa, you also, I personally find it fascinating that you have worked as a publicity and outreach producer for the film Picture a Scientist, and you're now adapting that to a book version. So I think that is fascinating for two reasons, because A, it's science, and B, it's probably mostly shaped by the fact that you have spoken to all of these different individuals, and that has given you the ability to actually convey information, text in a very fascinating way. You probably picture scientists and display scientists more profoundly than they actually are, because you're actually able to convey it in the most interesting terms. So can you speak about that for a bit?
Sure. Picture a Scientist is a documentary film that is about women in science and specific challenges that women and other underrepresented minorities face sometimes in science. And so it uses the poor analogy of the leaky pipeline, the idea that a lot of women at different phases in their scientific career leave the sciences. It's a poor analogy because the women are not leaking out. It's that they are choosing to leave, maybe because there's a toxic environment, they don't have the support that they need. Maybe something has happened that has shaken their confidence. It's wonderful to be here with all women. But the film, which I was not part of making, but was a beautiful film made by my friends and colleagues, Ian Chaney and Sharon Shattuck, is on Netflix now. And I don't know if it's available in Europe or not, but you can check it out. And it documents the stories of a geologist, a chemist, and a molecular biologist and a geologist who have different stories. And so I was privileged to be able to work on that film, and now I'm starting on a book. It's very new news, where I'm going to be talking about other stories from other scientists and their challenges, but more specifically also talking about social science research that shows what are some solutions to some of the challenges that women and others face in science. What are ways that we can make the culture of science more welcoming and more inclusive and less toxic for people at all phases of their scientific careers. So I'm very excited to be working on that. It's terrifying to work on a big book. So that's one of those scary moments that you have to embrace. But it's fascinating to look at where the research is at and to be able to, again, tell the story of scientists and where their work is not separate from them as an individual, and really their work is a product of all of their experiences and their journey that has taken them to that point. So I'm very excited to be starting work on that.
That is lovely news, and I'm really glad that you decided to share that bit of information with all of us here. So for this round, I honestly would want to ask all of our viewers to submit all of their questions, preferably in the chat, and we can move on through them. But while we wait for the questions, I wanted this last round to be like a lightning round of a sort. You have all, of course, as we all have, experienced a no. So some of you have experienced no's in your academic field more so than others for various different reasons. I want to know about the first and last no you obtained and how has that impacted you? In like the briefest way you can manage to elucidate it. So Professor Kozanic, I would like to start with you.
And how much time do you have? So it's so I'll just say I will not start from the beginning. I'll start from now the recent history. So it's grant rejections. So when they reject your finances for a project, so it's very common. The reasons for rejection here and in the US are completely different, which I will not go into. But facing the rejection is something in the beginning. It was very hard. Facing a rejection of a rejected paper is very hard. I remember when my first big paper in PhD was submitted to Cell, it was rejected. But I came back to my supervisor, professor, and I said, submit it to Nature, which is counterintuitive because you go down, you don't go up. And we submitted it and it got in, right? So just don't give up, even though sometimes you will in some cases, but just in the long run, it's a marathon. Forget the no's and just keep focused on yes.
Professor Leila, would you like to move on?
That was actually my answer as well. I don't remember no's. I just take them as a motivation for the next yes. And for sure, you will always get a no. You get a no on a daily basis from your family, and yet you achieve a yes. So it's pretty the same in the professional community as well. You just need to work harder, to leave your emotions sometimes behind, to stand up after you fail and search for the new door to open.
Oh, now would you like to move along?
Yeah, so I think I'll echo what was said. Persist, persist, persist. Never let a no bring you down, because that's just part of life. And as a young scientist, going into colleges, applying for colleges, like my younger brother will be applying for them soon, and no's come in then. So I think for me, of course, I applied to some places and they said no, and I said okay, that's fine. And then Vermont offered a great scholarship for out-of-state students, so that was even better. And then I guess for most recent no's, I haven't submitted many applications yet, as you can imagine, for any kind of grants or or publications. So maybe they just like request at the university level some little things, but nothing major so far. Yeah.
And Lisa?
I've gotten a lot of no's. I don't, my first one that I was actually just recently remembering, I don't know if it was my first one, but a very early one that I was remembering with my husband recently was shortly after I graduated from Cornell, but I had already had my first job. But I knew that I wanted to start doing more reporting. I applied to a fellowship program in Rhode Island in oceanography to work as a reporter. And I was so sure that I would get it. I was very, very confident. And then I didn't get it. But it ended up being a wonderful thing, because then I ended up applying as a result of that no to a reporting job in Washington, D.C., which I ultimately took. And I've been living in the DC area ever since. And my husband, who I was dating then, who I was seeing then, was able to find a job in Washington, D.C. And so we were talking about it and saying, had I gone to Rhode Island, we don't know, it would have been a totally different life. And so, those things are constantly changing. The one thing I'll say about recent no's, at the phase that I'm in my career right now, because I have my own business, I'm now in a position where I have to learn how to say no, to take care of my own mental health. So I'm having to learn to use that word more when people ask me to take on a new project or to do something new. I'm having to also learn how to say no in a nice way. And that has been a big adjustment for me, because I usually like to be able to say yes to people.
So that has been a great sum up of the question. I think it's very important to each of our viewers to actually understand that it's not just a no and that's it, but it's also, just like all of you have already echoed, is that it's important to just pursue and be brave about it and have courage within your specific field of interest. So we will move on to the Q&A section right now. So we have a question from Leila. Leila asks, can Lisa repeat the name of the Netflix film she mentioned her friends worked on?
Yes, it's called Picture a Scientist. And it just came out in Netflix, at least in the US. I don't know if it's internationally, actually yesterday, June 13th. Picture a Scientist.
Dada has a question. He has praised the panel and everyone here. He's, of course, very excited for this diverse field and this diverse panel. So he has a question for Ona. As a young scientist, you learn many things in the field of research and you gain plenty of laboratory knowledge. My question is, what are the 3 major competence skills that you learned during your journey?
Great, thank you, Dana, for the question. So yeah, the first thing that comes to mind for some reason is the presentation skills, how to present your research, because you need to make it understandable, as everyone here has mentioned many times. You don't want to overwhelm the audience with your science. It's amazing, whatever you're researching is great, you're interested in it, but just make it like a story. So just tell a story during your presentation. So I think that I guess that goes along the lines of the communication skills. So that while doing the research, just like my current Professor Kempa said, you have to be able to see those kind of unusual things that happen during the experiments, and be able to look out for this opportunity to discover something that's unusual, right? So you have to kind of be able to think actively while you're doing your experiments, and not just disregard it as, that failed, let's forget it. Sometimes those failed things lead to something wonderful. So keeping an eye out for those all the time. And then the third thing, I would say being concise. Getting to the point. And these days, people are getting busier and busier, and you don't want to come up to your professor and spend 30 minutes going around what you want or what you found last week. Just being kind of concise and getting to your point, so that people can, save time and don't walk around circles. So that, yeah.
Absolutely, I agree. With short attention spans just being more and more common, I think it's important to have that aspect of it. While we wait for other questions, I really want to know this from a professor point of view. So Professor Layla and Professor Amina, may you comment on one thing you want your students to be aware of when they enter your classroom? So Professor Layla, can you go first?
Can you just repeat the question, please? What do we want?
What do you want as a professor? What do your students have to know? Not academically based, but what kind of mindset do you expect when a student enters your classroom?
Well, to be respectful towards others and to be motivated to do the research. Those are two skills, let's say, that I expect from my students when they enter the classroom.
I think that, yeah, I definitely can see that, especially.
I wanted to point out from the talks of other panelists how interpersonal skills are very important, and Ona answered the last question really, really well, and she didn't point out any scientific specific skills, but she mentioned 3 interpersonal skills: how to be very concise, how to tell a story, meaning how to find the application for your research that you are doing. So those are really important skills that doesn't have anything to do with the science behind.
Professor Amina?
So I echo everything that others have said. Maybe just to add to, for students to be active learners. So also to learn during the class, and this was especially, I think, challenging now during this online school. So to be active as much as possible during the classroom time, and ask questions. Because when students come in, there are many different types of students. There are the extroverts, introverts. For some, asking a question is very easy. For some, asking a question is very difficult. So I think maybe this new generation is not as introvert as maybe previous generations, but I think it's important that students actively learn during the class, right? Be ready mentally to enter and be focused during the class, and then try to form a question. Doesn't have to be many, but a question. It doesn't have to be the most thoughtful question, but to be able to process the information and then at least ask one question. So I like very much when I have students when they ask questions. I mean, not constantly the whole class, but to have students ask questions during the class so that I can see that they are following and that they're actively learning during the classroom.
Thank you both for that answer. I think you summed that up beautifully. And from the chat, we have another question from Professor Layla. Dado asks, I'm glad to hear how your dreams came true from some courses regarding biomedical engineering. My question is, what were the biggest obstacles of becoming the person that you are today? What is the greatest advice that you have received?
Well, how to answer these questions? Biggest obstacles of becoming the person that I am today. Well, there are a lot of obstacles that I can talk about. Personal obstacles and obstacles that I have seen in my professional life, in my career. So I have pointed out that is really important what kind of person you grow up to be, because I say it like this: no one likes how to put that, researchers that you cannot relate to on a personal level. So you need first to build up yourself as a person, to go to the world, to see the world, but really see the world, to be the present in the world. And I think Ona also pointed that as a second answer during her talk. She said, really observe the experiment, observe everything that is happening. So that is my answer. Before becoming the researcher, the scientist that you dream to be, you need first to become a person that can carry inside that a scientist. And what was the advice? Well, it is related to the word no. Someone told me once time, never set for a no. Always try and search for more doors and more ways to fulfill what you want to achieve. It was the same with Professor Amina as well. When she got a rejection to her paper, she said, no, I don't trust this review, send it for some other review. So that's it, that's life. And research and everything, it is so simple. Just if you have the determination and the confidence, that is the crucial thing. And that comes from the person that you are. No one can tell you anything unless you believe in yourself. That's a full stop.
Thank you, Professor. I think we should just like have this momentum going. So Professor Leila gave her piece of advice. I would like for each of you to give a piece of advice that you find incredibly important, but also pertains to this educational field. So Lisa, would you start?
I think it's actually very similar to what Leila just said, which is basically take every opportunity that you can. And I guess I would expand that to say not just the opportunities that you're given, but go after opportunities. You are the only person who is going to ultimately, you'll have people who support you, I hope, and who mentor you, but ultimately it's you and your life, and you have to learn how to be an advocate for yourself and to go after the things that you want. And you should be courageous in going after whatever you want.
That's beautiful, honestly. I think all of our viewers will appreciate that. And Ona, would you move on?
Yeah, of course. So I would say always follow your gut, follow your intuition. If it doesn't feel right, just go along the path that makes you feel that you're comfortable. Your interests, follow your interests. Don't think it's too different right now. It's too different of a field. I think all of us have made it clear today that it's okay, and it happens very often in the science. And yeah, I guess for the one advice for this for the scientific side, don't get trapped in the details. Often go back to the big picture and go back to the fundamentals when necessary, just to keep yourself grounded in the scientific case.
Thank you so much. And Professor Amina, would you please give your piece of advice?
Well, they all have said beautifully what I would have said, so I don't have that much to add. Just one small thing is that it's important to have people around you during your career who are very supportive. So not even in personal space, but in that academic space, choose mentors, people around you who are supportive. So no man is an island. You're always affected by people who are around you. So make sure that people around you are as excited as you are, right? So that you can, that you complement each other and that they help you grow. So now being on the other side as a mentor, I see how incredible, how we have we can shape someone's or help shape someone's scientific path, or encourage them, push them on, and nudge them towards a specific basically give them encouragements even when experiments fail and so on. Papers are not accepted, and it's part of life, it's real life. So I think that's what is also keep in mind, to have those advisors and people around in the lab. Una has mentioned this, she's around it at this time now. So it's those are very important things to keep in mind as well. So
thank you all very much for the piece of advice, and of course thank you all for participating and making this panel actually possible, because I'm really glad that this panel turned out the way it did. I had very specific people in mind for this, and I really wanted all of you to agree. I wanted someone that is just basically starting off their career. I wanted someone who had major and important and fascinating experience with scientific writing and digesting and incorporating information that is very relevant to STEM education in general. and of course, people that were somewhat one step in the industry, and then this absolutely conflate all of these experiences. So I would like to thank all of our viewers for participating in today's panel, for all of your questions. And again, the biggest thanks goes for me to all of you for participating in this panel. I had a wonderful time. I hope that you all did as well, and that our viewers obviously enjoyed the panel. So with that, we're all signing off, and thank you all for coming.
Bye-bye.